Hi guys, welcome. We should be live now. Welcome to the first ever .NET CZ online meetup. We have a exciting speaker today, Dominick Baier. We'll be talking about OAuth and authentication and how you can solve the problems with authentication that you're dealing with in your projects. My name is Jakub Janis. I'm an organizer of the former Prague.NET meetup, and I'm excited to tell you that from today onwards, we are joining forces with .NET CZ, and we'll be organizing these meetups together. It's a non-profit organization which started organizing meetups and conferences here in Prague. Unfortunately, due to the situation with Corona, we cannot host meetups in person for the time being, but we'll try to bring you as much awesome content as possible in the online form. It's the first time that we're hosting this online, so hopefully we'll go without any technical hiccups, and you can enjoy all the awesome content Dominick has prepared for you. As far as the future events, we'll try to do as many of these meetups online and then in person once the situation calms down a little bit. Unfortunately, we were trying to organize a conference for 2021, but as it's still unclear if these sort of large events will be possible, we postponed this until 2022. So we'll keep you posted on that. That's all from me as far as the organization stuff goes. So over to you, Dominick. Take it away. Enjoy, guys.
Okay, am I live? Excellent. Okay, cool. Let me share my screen. So cool. Let me see if I get everything here up and running. Okay, cool. So welcome, first of all. This is the first time I'm doing this talk. I'm actually looking forward to that. I've been working on that for a while, or the idea at least. Thanks for the invitation, and we'll just get started. So the thing is, I will from time to time check back to see if there are any questions, or maybe the moderator can whisper me some questions in between, but we will also have at the end time definitely to answer questions. So we'll see how that goes. I'm actually not very experienced with this Google YouTube broadcasting thing. So let's see how that goes. Anyways, so yeah. So my name is Dominick, and for those who know me, I've been, spending the last 10 or 15 years basically implementing what is called security token services, and I've been working on this. The main thing I've been working on was this thing called IdentityServer, and basically we've been implementing OAuth protocols. Yeah, and OAuth is not just a single protocol. There are many protocols, or a protocol family. And if your day-to-day job kind of is implementing these things and helping customers to apply it, you tend to dig deeper and deeper and deeper into details, and kind of not get a chance anymore to talk about the bigger picture here. So the whole idea of this talk basically is to go one step back and reflect on OAuth in 2021. And not everybody is an expert, and assuming you're gonna start out with this technology, or you want to learn how it works, or or are confused by this tons of information out there. So this is kind of like I want to give you like a structured introduction. Okay, so this is an introduction talk. Yeah, it's basically going step by step into what I think are the good parts of OAuth, or the essential parts, basically. Yeah. So, anyways, as I said, for those who know me, I've been working on this thing called IdentityServer, which is an OAuth implementation. And just to get this out of the way, because I'm getting tons of questions every time I'm doing anything online, we recently moved IdentityServer from one repo to another. We basically created a company around this because we needed a more sustainable business model. So as part of that, we created this thing called Duende Software, which is the new home of IdentityServer. And as I said, we try to find a way to make this work both for individuals, hobbyists, researchers, small companies, as well as the big enterprises. And we came up with this, what we think works quite well. It's basically, IdentityServer still stays completely open source. And if you are an individual or a small company making less than $1 million revenue per year, it's completely free. Yeah, you can use it for your production environments. And if you are making more than $1 million revenue, then we have some commercial licenses for you that fit your needs. So that's all I want to say about this. To get out of the way, this talk is not related to IdentityServer at all. I'm showing a couple of demos using IdentityServer as a engine, so to speak, but it's all about protocols. Cool. So as I said, if you would, let's say your boss would come through, to your office or, call you on Zoom, wherever you take calls these days, and say like, you have to learn OAuth, yeah? Where would you start? Yeah, and what you're seeing here on that screen is like basically the last 10 years or a little bit more of OAuth history, yeah? So many documents have been created, many satellite specifications have been created, many, relevant stuff, basically. But is it all relevant? That's the big question here. Like, if you want to start learning this technology, where would you start? Yeah, and obviously, this kind of is inspired by the good parts idea. Basically, any technology which is around for quite a while and is successful, yeah, things get added to it to cater for this new scenario and that new scenario. And, not every feature that is around or has been added is definitely, necessarily a good feature, right? Or did stand the test of time. So in the same vein of JavaScript, the good parts, I want to show you what I think is essential to learn if you want to start today, or even if you are, doing it already, and you want to see what's going on, what's going to be the future of that. That's that. Unfortunately, unlike what this picture implies, is I probably cannot save you from reading the other pages. Yeah. So if you really want to architect systems, you need to know probably also the bad parts to make a good decision why you would not use them. Yeah, but for today, let's just focus on the happy path, I guess. Cool. So that's my agenda. Yeah. So why does OAuth exist in the first place? What are the two protocol flows that you need to know and need to learn, and you can forget all the others, which is probably the good part of that. I want to show some typical application architectures, and then probably, the most, in my mind at least, the most important thing that got built on top of the raw OAuth spec, which is OpenID Connect, along with its metadata feature, which is, the one more thing I would recommend you learning. And then at the end, I give you places where you can go, on from there if you want to learn more and, dive deeper into those details. Okay, cool. So let's get started. So why does OAuth exist? Yeah, that's a good question. And basically, let's go back 10 years in time or even more. Yeah. So, people wanted to access web services, as they were called back then, if you remember that, right? There were web services, and that was a very enterprisey thing because there was this whole web service, movement with SOAP and all of these things, and this was very enterprisey. And this, in these enterprise environments, this did work, I guess, to a certain degree, but there were companies out there like Google and Twitter, all of these upcoming, Web 2.0 style companies. They were trying to expose, like in essence, web services, but they didn't call them web services. Yeah, they called them HTTP APIs or RESTful APIs, even if they weren't RESTful at all. You name it, right? So they were looking basically for a way to access these, to secure these APIs and a way to securely call them, yeah. And as I said, pioneered, I guess, by other protocols like Kerberos even earlier, and then WS Star, there was this idea of using token-based security, yeah. That instead of sending my name and password to a service, I'm using this substitute, a token, yeah. And there were tokens around by that time. And they were called SAML tokens, yeah. And if you look at that again is very, very enterprisey, right? It's XML, right? And it's very verbose and all of these weird things like namespaces. And for people who know SAML, they know I already stripped out lots of it to make it actually fit on one slide. Okay. But yeah, tokens had some interesting, concepts. Like, first of all, there was this concept of an issuer, right? So you are basically trusting a third party or some entity in your company to issue these tokens that gives someone access to a service. Yeah, signatures were involved to make sure these tokens cannot be tampered with anymore after they've been created. Yeah, there was the idea of that these tokens are not valid forever, right? As opposed to a long-term secret like your password, for example. A token had a very specific time window. Yeah, it started here and ended here, and after that, the caller need to get a new token, and the attacker, for example, could not use this token anymore. There was the idea of scoping or audience restrictions, meaning, again, these tokens could be issued for very specific services. Yeah, they were not valid everywhere. Again, as compared to a master key like your password, where you could access everything, this token was scoped to a certain destination and scoped to a certain time. Okay, and there were other concepts that they mixed into the SAML tokens, like information about the authentication details of that user, or other arbitrary claims that describe, I guess, typically the user of that web service. So again, this technology did exist, but for building these, for the lack of better term, Web 2.0 kind of APIs, like the Google, the Gmail API or the Twitter API, they didn't like that. They were verbose, they were enterprisey, they sounded not the right choice for building these newer things. And one of the main reasons, to be honest, was that for these scenarios, there was one really important requirement which wasn't really didn't really exist in enterprise software, which was the third-party requirement. Enterprise software was completely optimized for first-party scenarios, right, where the caller and the service were like the same company, the same entity, maybe a partner company, something like this. Yeah, but if you have ever done any type of systems integration in this world, I mean, good luck finding two XML parsers that actually worked with each other, right? Like if the caller was .NET and the receiver was Java or any other combinations, it was hard, yeah? But this requirement actually enabling third parties to call our APIs was key to this whole movement. Yeah, and again, one of the standard examples here is like Google enabling a third-party ecosystem to add value to their APIs, like the Calendar API or the Mail API, right? So what if there is a third party who manages your out of office replies for you, right? How would they be able to set them or read them or update them without you giving them like the password to your Google account, right? Which is obviously not what you want to do. So, they were looking for a way to enable these third-party scenarios, and that must, quote unquote, be simple. Okay, and SAML and WSTART definitely weren't the answers here. Okay, so that's kind of like the reason why this OAuth thing was enabled, invented in the first place. You had to find basically a simpler version of how to access APIs using a token-based approach. So before we move on, I have to introduce a certain terminology to you, which are words that I'm going to use over and over again, just to make sure that we are all on the same page. So basically, what OAuth brings to the table is the idea of that there is there's a token service, right? So if somebody wants to access an API using a token, somebody must issue these tokens. And in the OAuth world, this thing is called the Authorization server. Yeah? And that's a very confusing term because many people think that is kind of that this would involve authorizing access to services for users, but it really is for the callers, for the pieces of software that are calling into your code. And the other thing which basically typically people call APIs these days, or HTTP APIs, whatever, they call it in OAuth the resource server. Yeah, and the things that call or want to call your resource servers or your APIs for all practical purposes is called the clients. Yeah, clients are basically a piece of code that the code that makes the actual network call to your APIs. There are two types of APIs that the spec designed for. One, what they call confidential APIs. Basically, confidential clients. Basically, clients which are installed on trusted hardware, like on a server. That's typically what that means, right? That the client is some piece of code running on a server that you trust, and that might be either on your own servers or on maybe partner company servers, or you have some sort of business relationship to someone, and they, assure you that they are storing whatever secrets they need on their servers. Yeah. The opposite of that would be called public clients, which are basically, things that you cannot trust. Yeah, like mobile applications running on some random phones, right? Or browser-based applications running in, browsers on user machines that you cannot trust. Yeah, and there are different security properties here, and as we'll see, the confidential client type is much more common these days than the public one, because again, security properties are better. Okay, then the next thing is that these clients might have what the spec calls resource owners, and that is again a very confusing term. It kind of means that they own that there is some data on the resource server that belongs to the resource owner. It's not that they own the APIs or the servers, or they actually own the data. It's more like that there's a relationship here, that there's a resource owner that wants to access a resource server using a client, and on that resource server, there is some data belonging to the resource owner. And if you want to avoid this confusion altogether, I just like to call them users. Yeah, so users use clients to call APIs. I think that would be OAuth in a nutshell if you would use, 2021 terminology, whereas the old OAuth terms sound a little heavy-handed, I guess. Yeah. But it's very important that they make a distinction between users and clients. Yeah, so users are basically human beings, carbon-based life forms, if you like, of your system, whereas clients are software, basically, silicon-based life forms, and they access the data on behalf of their users. And then, the details, we'll get to the details, but in a nutshell, how this works all the time is that the client requests a token, or in OAuth terms, asks for authorization, to get a token, and If that's successful, the authorization server returns the token, and then the client application will use this token to access the resource. As we all know, these tokens typically are scoped to specific resources, have a limited lifetime, right? And after when they expired, the client needs to basically start again and get a new token, and so on and so forth until all the work is done. Another really important detail here is in the OAuth architecture assumptions is that the authorization server and the resource server are owned by the same entity or company, right? So if you as a company offers APIs to the world, you would have your own authorization server that knows about your APIs and that can issue tokens for your APIs. That's often another common misconception here when people say, like, can I use the Google OAuth server to authorize access to my APIs? And the answer is no. You can only use the Google OAuth server for Google APIs, and you can only use your resource server for your APIs, and so on and so forth. Yeah, so there's typically a very tight coupling between the authorization server and the resource server. Also, for example, that the resource server needs to understand the tokens, right, that this authorization server has issued, and the semantics of these tokens and the contents as well. So that's basically the big picture. So let me see. Do we have some questions here? Is this even feasible with me with the delay between these? I can't even open the one. Okay, so we'll take questions at the end. Okay. Where is my Google? Where is my PowerPoint gone? Come on, come back to me. Okay, here we go. Excellent. Okay, excellent. So.
Dominic, can you just click on the pop-up to hide the message at the bottom, so we see the full screen? Thanks.
Okay. So if there are any really, if you want to from time to time just ask some questions that you see in the chat window, just let me know. Yeah, that's totally fine. Feel free to interrupt me. Yeah, but it's it's a bit distracting just switching back and forth between the windows, I guess. Yeah. Okay. So, if you looked at OAuth like, recently or maybe a longer time ago, you read the spec and you saw that there are what they call protocol flows. And flows are basically OAuth protocol messages going back and forth between the client and the authorization server that are optimized for certain application scenarios. And there were 4 of them. And 2 of them are basically deprecated now with the upcoming OAuth 2.1 specification. And in the end, we realized that there are really only 2 types of applications you're typically building. The one type is more like, headless, machine-to-machine, server-to-server style communication. And the other one would be interactive applications like, web applications or mobile applications, things like that. So all of the other flows are kind of not really recommended anymore. And that, as I said, that there were 2 flows left. Let's focus on the first one, the simpler one first, which is the machine-to-machine communication. And that is called the client credentials flow, or the spec also calls them grant types sometimes. But basically, the idea is that in this scenario, there is no human being involved. It's just 2 machines talking to each other. And the way this works is basically, here's our client, and here are our resources, and they have names. And in OAuth speak, they are often called scopes as well. And then here's our authorization server. So now, basically, the assumption with all of these flows is that the authorization server knows all about the resources, it knows all the clients, and that there is an a priori relationship between them. Yeah, so that these resources are registered at the authorization server and the clients are registered at the authorization server, and also very typically the authorization server knows what type of client it is. So is it like a server-to-server client, or is it an interactive client? And also the authorization server, and that's where the name comes from, also very often knows which APIs or resources this client is allowed to call. Okay, so in this very simple scenario, the client basically opens an HTTP connection to the authorization server's token endpoint. There is some authentication going on, so that the client authenticates with the authorization server with client ID and client secret. And then basically, in essence, what the client says, hey, I want, or give me a token that I can call API 1, okay? And the parameter that is used to specify for which token this, for which resource this token is for is called scope. Okay, and now the authorization server will basically authenticate the client, make sure the client secret is appropriate, make sure that this client is allowed to call this API, and if all of this succeeds, it will send back a JSON object which contains a field called access token in it. Okay, that's as simple as it is. Now, the OAuth spec itself predates, for example, JSON Web Tokens. So the OAuth spec doesn't say anything about how this token looks like, what the contents of this token are, and so on and so forth. But today, pretty much every popular implementation kind of uses the JSON Web Token format because it's so popular. It's there are libraries for that on every platform and so on. And in case you haven't seen it, a JSON Web Token really is a JSON object that you want to protect, right? So and to protect this object, you basically need to sign it, and the signature serves two purposes. One is that you can detect if somebody tampered with the contents of this payload object, and the second one is if you can validate the signature successfully, you know where the data comes from, right? Because there's a relationship here with key material. So the actual data that you want to protect in JSON Web Tokens are basically some key value pairs, or called claims, basically, that describe the access token. And what's typically in this access token usable data is where the token came from. That's like a symbolic name or the DNS name of the issuer. Then the time window I mentioned earlier, right? So it's the issued at claim. So when was this token issued and when will it expire? And then for which resource this token is good for and who is the client that requested it, right? And if you think about it, that's pretty much exactly what SAML did, and where people thought like that's too heavy-handed and so on. But it turns out the actual type of information is very important. XML was a very verbose data format, and that's how it looks like now in the JSON Web Token format, which actually does fit easily on a slide. The wire format for a JSON Web Token is basically you take the header part, which is a JSON object describing the signature algorithm and which key material was used, and you base64 URL encode that, put a dot here, and then use base64 URL encode the payload, and then basically hash that string and then sign that string, and that is basically now the signature of that hash, which is attached to it. Okay, so that's how a JSON Web Token looks like, and that's what the OAuth authorization server returns. Now, just to be clear, the spec, as I said, the spec does not mandate that format, but it's very popular these days. You might come across other OAuth products which do it differently, but as I said, JSON Web Tokens is a pretty common thing. Cool. And then once the client has that token, then typically the client is ready to call the resource. And the way this works is that the client puts that token on a special HTTP header called the authorization header, uses the word bearer here, which is actually a registered word from the OAuth spec, basically telling the recipient, hey, this is an OAuth token, and then makes calls to that protected resource. Yeah. Now, there are a couple of rules around these access token and how you handle them. The first one is kind of important because I've seen it go wrong in many places. Yeah, where is that the token format and the token contents and even what these claims mean, that's a private implementation detail between the authorization server and the resource. Yeah, the client is simply a forwarder, right? The client asks for a token, and whatever it gets, which is an opaque string from the client's point of view, gets sent to the API. Now, with the knowledge of that is a JSON Web Token, some developers write code where the client makes an assumption that this is a JSON Web Token, starts to decode it, yeah, and poke around in the token because they need some information that's in the token. Yeah, this is not how it's supposed to be. The authorization server and the resource are free at any point in time to change how these tokens look like, and this would break clients. Yeah, so don't do that. Yeah. We'll talk about a different way to make this, to do this that works for most scenarios. But the access token is actually forbidden to, touch at the client, apart from forwarding it basically to the API. When the token arrives at the API has a couple of validation rules. Basically, it checks the signature. It checks certain fields in the header, like the type field must have a certain value. The ISS, the issuer claim, must have an expected value, basically saying like, hey, I expect this token to come from our authorization server, so that should be in there. The time window gets checked, like the current time must be before the expiration, but after the issue date. And then, of course, the scope basically says, hey, this token is for API 1, so if API 1 receives that token, API 1 should make sure that this actually matches the scope, right? And if a token for API 1 is sent to API 2, then API 2 should say, hey, this token is not for me. Okay, cool. As I said, this talk is not really too much about code, but let me show you a simple example of that. Let's run IdentityServer, and let's have a look at a C# sample. And you can see basically the way you request a token is you are basically opening an HTTP channel to the token endpoint of the token server. You pass in some information like the client ID and what's the client secret, and basically what's the resource that you want to access as part of this scope parameter, right? And then when I run this, we can have a look at the token back here. Okay, so here you see that is basically the raw token response. Here's the JSON object I mentioned earlier. Here's the access token field, like the expiration, like how long will this token be valid for? And then you see that is the decoded version of this access token. I'm doing exactly that, what you should never do, like decode the token at the client, but that's for, educational purposes. So you see there's the algorithm, which is RSA with SHA-256, and here's a key identifier. Here is the issuer field, not before, issued at, expiration, and here's the scope that this token is valid for. Here's the client ID, and that this JTI is basically a random value that you can use for replay protection if you want to enforce like single-use semantics. Okay, so that's the machine-to-machine style scenario. It's super simple. It's a typical, like just a request and response relationship here. Now, when you're sending now this token to the API, there are two status codes that you can expect in an OAuth context. One is the good old 401, the unauthorized, and what this the status code basically means is that you're trying to access a resource, and this resource requires a credential or a token, and for whatever you send along as a credential was not valid. Okay, either maybe because you did not send a credential at all, or maybe the token comes from an untrusted issuer, or the signature validation failed, or which is probably the most common reason why this would fail is because the token has expired. Okay, so as you've seen in the response from the token service, that there's an expires in field, and that tells you how many seconds into the future this token will be valid for. In our case, this was 1 hour. And when you're getting a 401 from the token from the API, then most commonly the reason for that is that the token has expired. In that case, get a new token, retry the operation. There's a chance this will succeed. Okay. The other typical response code you can get is the 403, which is basically forbidden. And what that basically means is that, well, the token you send is perfectly valid. Okay, there's nothing wrong with the token, but you are trying to invoke some functionality which is just not allowed. Yeah, and in this case, there is no use in getting a new token and retrying the operation because, as I said, the token was fine, but you are just not allowed. Yeah, so these are the two typical scenarios you're running into or can run into. Okay, so once you have that token in the client, obviously what you want to avoid is getting a new token for every single call you're making. So you have to manage those tokens somehow. There are common strategies for that, like storing them like in memory, or maybe if it's a more complicated thing, maybe you want to have a distributed cache. Maybe you have sessions or databases, store it somewhere. Yeah. And as I mentioned earlier, you should be prepared anytime for getting a 401 back from the API. And if you're getting that, then you typically want to have some logic saying like, okay, give me, I'm getting a new token, and then I'm trying to, retry the operation, and chances are that it might work. Okay. Also, as I said, you want to probably use some sort of caching mechanism to, get like a time-bound storage here. Typically, you want to combine these two things. Okay. Now, one thing that is often a little bit confusing, and it is confusing because it basically is notoriously under-specified, is how the client expresses to the authorization server which resources it wants to access. Okay, the original OAuth spec basically is very, has a very abstract notion here. It basically just says there's this thing called the scope parameter, and the scope parameter is expressed as a list of space-delimited case-sensitive strings. Okay, the order does not matter, and kind of the assumption is the longer the string, the more access you have. Okay, and then, which is sometimes a little bit of a pity with the OAuth spec, is they also, by the way, maybe they also ignore this or whatever. So how it's used in reality is that, as I said, typically you give invocable functionality logical names. That's kind of like how it is. And the GitHub scope design is a really good example of that, how this is done in many of these end consumer facing services, right? Where in this particular example, let's just assume GitHub is one big API surface, if you like. And then they gave different feature areas names. Yeah, like if you want to access a repo, there's the repo scope. If you want to access the user details, there's a user scope. If you want to access the package feed, there's a packages scope or name. Yeah, and then you see that sometimes the name on its own is not enough. Then you need to qualify that with like write packages or read packages or delete packages. And you see also that there's a bit of a evolution here with the underscore. Sometimes it's an underscore, sometimes it's a colon, right? So basically the idea is that the authorization server defines these names and what they mean. Then the client can ask for them, and if the client has access to it, it will get back a token, and then the API can say, okay, you have the right packages the write packages scope. That means I allow you access to my write packages functionality, I guess. Yeah. The same scope parameter, right? Because it's, as I said, very under specified, but in a totally different style is, for example, what Google is doing. Yeah. So Google has a bit of a different mindset here. They rather think in terms of products. So you see you have the BigQuery product and the Gmail product and the calendar product and so on, and all of them then have basically prefixes in as URLs. Okay, these are not the physical URLs where these things are running. It's more like they chose the URL format to have a string format with built-in hierarchy. Yeah, and then you basically see, okay, every API has a prefix, and from that point on, I guess, the product team were free of naming these scopes underneath that prefix. Okay, so again, from an OAuth point of view, that's exactly the same, but this is a different way of styling it. And this type of style I see pretty often in like company or enterprise scenarios. That's kind of like the attitude here of having namespaces, I guess. No, cool. Excellent. So that was the first flow to understand or to learn. It's called the client credential flow, and it's super simple. Client opens an HTTP connection to the token endpoint, asks for something, gets back the token or not, depending on what you're asking for, and that's it. The other flow is, and as I said earlier, this flow is designed for non-interactive applications where just two machines talk to each other, and that's fine. The other type of flow is designed for exactly the opposite, where there are actually interactive users. Yeah, like where you need to incorporate user feedback, like maybe login pages or consent pages or any other type of UI that you need to show to an end user, and that UI will basically shape the outcome of the token request. Okay, this is for all practical purposes done in browsers. Yeah, where the user is taken through a series of steps, and at the end of these steps, then we return back to the client application, returning them the tokens, basically. Yeah. So let's have a look at this flow at a higher level. You might have heard of this thing called PKCE, the PXE extension as well. I'm not going into details for PXE, but here's a link if you want to read more. It's a mandatory little extension these days to protect against certain types of attacks. But as I said, this is not our main focus here for today. Okay, so how does the authorization code flow work? And the way they designed this is to basically divide the protocol flow into two steps, basically. One is called the front channel, which basically takes care of all of the user interaction bits. Okay, that's where the browser you send the browser to some place. There's where the login page gets shown or other pages get shown, where authentication happens of the user, and also by virtue of using the browser and its cookie state keeping is the enabler for things like single sign-on as well. And the outcome then of that front channel is then used in a second step called the back channel, where ultimately the client then retrieves the actual tokens. We are trying to avoid to transmit the tokens over the front channel, because the browser is the least trusted part here in that whole chain. So that's why the front channel does not deliver the tokens directly. There's an intermediate step called the back channel that then gets the tokens, which is a server-to-server call. Okay, so let's have a closer look at how these things work. So the front channel request always starts at an endpoint called authorize. And again, the assumption is that the client is pre-registered typically. And the client passes in, okay, I'm the client called client, and I want you to come back to me once all of your interaction is done to this particular redirect URI, which is the callback URL, okay? So this callback URL must be pre-registered at the authorization server. And, you can imagine that, like whatever the authorization server sends back to the client is sensitive data. So you want to make sure it arrives at a very specific place. And that is, not controlled by any type of user input or whatever. And then, response type code means I'm using this authorization code flow. Scope, again, here's the scope parameter, just the same as we've seen before. This is basically how the client expresses what it wants to access. And then there are some more protocol stuff that is mostly security related, like state is for binding that request to a user agent, and the code challenge is basically this PXE extension I mentioned earlier that sends basically the hash of a per request secret, which makes it harder which basically prevents an attack called code injection, which, as I said, is not our main topic for today. Okay, so now basically the client application hands over control to the authorization server, and now the authorization server can show whatever UI it wants, right? So very typically, this UI will involve a login page, right? So a user is basically, or a client is requesting a token on behalf of a user. So we need to know who the user is. Otherwise, we cannot embed the right user information into the tokens. Now, if, let's say, the user opened the fresh browser, chances are that it will see a login screen. If there are, an existing logon session going on, then maybe this login screen does not get shown. Yeah, I mean, you can compare this to Google, for example. Yeah, and that's called single sign-on, right? So if you are already in an existing session, then you don't need to re-authenticate again and again and again. Yeah. Another step that might occur after authentication is what is called consent. And the idea of consent is to involve a human being's brain, so to speak, before we actually return tokens back to the client. And the idea is to basically tell the human in front of the screen, like, okay, this is the authorization server. Here is who we think you are, and this is who we think the client is. And that's what the client is asking for. And does this all make sense to you? And if you say yes, then, well, exactly that will happen. The authorization server will issue back an access token back to the client. Okay. So as I said, this is an attempt to involve a human being into the decision making. And very often then you can say, okay, this makes sense. Let's remember this decision for these combination of parameters here. And if and showing that screen is not mandatory. It's up to it's an implementation detail of the authorization server. Some decide to do that for third-party applications, but not for first-party applications, and so on. Yeah, so it's depends a little bit on the implementation details. Okay, so if the human being pressed the yes button, then this is exactly what's going to happen. And all of that information is being captured now on the authorization server and is associated with what we call an authorization code. Okay, so this imagine there's some database somewhere which has a code, like a random number, and then it says, okay, that's for user Bob, for client, and for the scope API one, and so on and so forth. So all of the information is being captured basically, and we just return this authorization code over the front channel. Okay, so basically we're trying to minimize the information going over the front channel, and then the client will then open a back channel communication, again authenticate with the token endpoint, and then send that code it just received over the front channel back on this back channel communication. And if all of the information now matches up, basically it's the same client that the client authenticated, it was successful. The code belongs to the same client from the front channel. The redirect URI was the same one used here, and the per request secret, this PXE secret, matches up as well. If all of these things match up, then the authorization server will return back the tokens in this case. So it's not only one token, the access token, but there's a second token involved, which we'll talk about in a second, called the refresh token as well. Okay. This access token typically looks, well, very similar to the one we've seen before, but typically has some additional information in it because there's a human being involved now. It typically has some additional information, not only about who is the client and what the client wants to access, but also who is the user. And a very common claim type for that is called the SUB claim, the subject identifier claim. And maybe, the API cares about how the user did authenticate. Yeah, there were some standard claims here, like AMR stands for Authentication Method Reference. Again, this is an implementation detail of the authorization server. And, typically, as I said, the API developer belongs to the same organization that the authorization server is running. Yeah, and that's so they can make certain assumptions of what they think would be in that token and what that means to them. Okay. Cool. So now, the token management with interactive application is a little bit more complicated, right? So in the pure server-to-server style, the server can at any point in time just do another request to the token endpoint, get a new token. But if you are having a human being sitting in front of the machine, you cannot just anytime you want to do another redirect with the browser back to the authorized endpoint. That would not be very UX friendly. Yeah. So we need a better way to manage this token lifetime without having to involve that human being all the time. And that is what is called a refresh token. And think of refresh tokens is pretty much like a sliding cookie, where, basically you have that cookie and then you're sending it and you're getting back a new cookie, but it basically, extends the lifetime into the future. And that is exactly what a refresh token is too. The only difference is that with sliding cookies, the browser is doing all of the hard work, whereas with refresh tokens, the client needs to do all of that work. And, it's not that hard. Basically, the way this works is that when your token has expired, and when the token has expired, either by looking at the expires in field or by waiting for the 401 to come back, you take the refresh token you got from the authorization server and send it back to the authorization server, re-authenticate with client ID and secret, and then you're getting back a new pair of access and refresh tokens. Yeah. Sometimes you're getting back a new refresh token every single time. Sometimes you're getting back the same refresh token. That's again an implementation detail of the authorization server, and then you have a new access token, which again is valid for, in this case, 1 hour. Right, and then after 1 hour, you start over and over and over, and make sure you have the access tokens you need to continue working on behalf of this user. Yeah, there are these refresh tokens. The nice thing about refresh tokens is that there are also ways to revoke them. Yeah, so let's say, for example, the user gave an application long-lived access to its data. Then what this application typically offers is some sort of self-service page where the user can say, okay, maybe I want to now revoke access for a particular client, to my data. And then they offer these types of pages here. That's the one from Google. Of course, they don't use the word refresh token or whatever. They just say these are apps connected to your account. But if you click the remove button, that basically is exactly what it means. It deletes the refresh token, and from that point on, the client cannot renew access anymore. Okay. Again, I can show you a demo here. This is using ASP.NET Core, and well, we don't really need to look at the code. It's more like the user experience, I guess. Okay, so in this case here, I'm trying to access some secured resource, right? So I'm clicking this link, and this makes the application trigger the front channel part of the protocol. So I'm ultimately ending up on this login page here. So I'm logging in with my account. As you can see, for this client, consent has been enabled. So it says, hey, it wants to access API 1. It actually also tells you, and this will also result in a refresh token. Are you okay with that? You are Bob, and that's me, and that's the application, and so on. And then we say, yes, please. And then I turned on saving the tokens in my session. So you see, basically, we end up with an access token here, and we end up with a refresh token. Now, the refresh token, as you can see, is not a JSON Web Token because there are no dots here, right? So it's just a random string that associates with data stored in the authorization server. But the access token, as I said, is a JSON Web Token, so we can have a look at it. There's my favorite JSON Web Token debugger tool, so you can paste that token in here, and then it will decode the token for you. And as I said, it looks very similar to what I've shown you earlier. Here's the header of the token up until here, and here's the payload, right? So here are the claims like issuer, not before, issued at, expiration, all the scopes, authentication method, client ID, user ID, subject ID, authentication time, so when did the session start, session ID, and so on. Okay, so that's basically how that looks like. Cool. So that's revocation. Oh yeah, and this here is end user revocation, right? Like a self-service style thing. You can also programmatically revoke tokens, which is very recommended. For example, let's say the user logs out from the client application. You still have this refresh token. It would be good, security hygiene to just get rid of it. Yeah, like revoke it, or maybe if you think about native applications, if you uninstall the app, yeah, and you still have this refresh token hanging around. I mean, yeah, of course, deleting it is kind of similar, but actually revoking it, would make it unusable. And if an attacker finds this thing 1 week later in some old network trace, it cannot use it because, well, it's been revoked. Okay, so that's something I would recommend doing. Excellent. So, and as I said, these are the two only flows that you have to learn. Yeah, forget everything else. There's this new revision of OAuth coming out called OAuth 2.1 very soon, and they deprecate all the other flows that you might have heard or learned in the past. They are not relevant anymore. If you want to build a new application, a modern application, focus on exactly the two flows I just mentioned. Okay, so it turns out now that there are basically 3 types of applications you're building, really. Yeah. Whereas one is the machine-to-machine scenario. We talked about this already in enough detail. And if it's an interactive application, I really, either it is an application that lives inside a browser, or it's an application that lives outside a browser, right? Browser-based applications, I guess that's easy. It's either like a server-side application, like an MVC application, or it's a SPA, like Angular, React, whatever, or Wasm, right, like the Blazor, and so on. Or it's basically a native application that lives outside a browser, like a mobile app or a desktop app. Yeah. So these are basically the things that you build. Now, for browser-based applications, the guidance is pretty simple. Yeah, regardless what you're building. You have an application backend, an application server, and that typically has the following features. It has support for OAuth and OpenID Connect, which we're going to talk about in a second. It has some sort of session management built in to be able to manage the artifacts from OAuth, like the access token and the refresh token, to store them somewhere. Based on top of that, you typically have some token management that helps you with refreshing those tokens and revoking them, and all of that token lifetime management. And then you have some sort of UI, and that UI might be a server-side UI, or it might be a client-side UI. But basically, the idea is that you have a UI. The UI doesn't need to know anything about these token details. It uses services provided by the application backend, and the application backend, all of the hard security stuff happens, right? And if you're doing ASP.NET Core, then all of this exists and is conveniently usable by developers, and we are in very good shape. If you are not in the browser, well, guess what? You have to open a browser. Yeah. So if you're writing a native application, then the recommendation is that just for the token request part, you're popping up a browser. You're doing you're building this URL to the authorized endpoint. The browser will take over. All of the user interaction will take place in that browser, and then every native platform has a way to send data back from the browser back to the native application. So they basically send you back the authorization code, and then you open the back channel application from within the native app to the token endpoint of the authorization server. And from that point on, it's all the same. Okay, so that's basically how that works. Cool. So the last couple of slides are really about this one additional thing that I would encourage you to learn, which is OpenID Connect, which is basically an authentication protocol on top of OAuth. And I'll show you in a second why this is necessary, because probably you have heard the name OAuth authentication many times, but it's always a lie. Okay, OAuth is not an authentication protocol, but it can be, there are extensions to it that can be used to turn it into an authentication protocol, and they are called OpenID Connect. One thing that OpenID Connect actually introduced, which was completely missing in OAuth, was the concept of metadata. And I'll show you in a second, or I'll show you right now what that really means. So in OAuth and OpenID Connect, there's a very important concept called the authority. And the idea is that this is the entity you are establishing trust with. That's the entity that you are accepting tokens from, okay? And again, if you look back, if any one of you did WS security or SAML or whatever, there was a very complicated process of establishing trust with a token issuer based on XML signatures, and you had to establish keys up front before you could even start using that token service. In OAuth and OpenID Connect, they made a different decision that basically you establish trust to a DNS name, basically, and that DNS name is authenticated using HTTPS. Yeah, and then underneath that DNS name, there is what they call a well-known endpoint, and that gives you metadata about that authorization server or token issuer. Yeah, this concept. Well, and the main benefit here is that you don't have to hard code any protocol endpoint URLs or key material or whatever. You can basically simplify the client configuration tremendously by basically just specifying the authority, and then the client library can then construct the URL to this metadata endpoint and auto configure itself. And this was actually introduced by OpenID Connect, but the OAuth people thought that's so useful, let's backport that concept into OAuth itself. And if you would talk to a pure OAuth server supporting that feature, then they have this well-known endpoint called OAuth Authorization Server. But to be honest, very, very often, OAuth and OpenID Connect are going together so well that they are typically both implemented. And that means that you basically start here and you get your OpenID Connect and your OAuth metadata. Yeah. So let me quickly show you an example of that. So you see here in ASP.NET, for example, when you see how the OpenID Connect /OAuth handler is configured, basically all they really want to know here is what's the authority, right? And that is obviously a development environment here, but imagine in a production environment, this would be https.login.mycompany.com, whatever, right? And basically what the client library is doing here is it's constructing the path to this metadata document based on the authority, and can then get out of, like all of the physical details, like where's the authorized endpoint, where's the token endpoint, what's the key material I have to use to validate the tokens, and so on. Yeah. So let's go back to PowerPoint. So that's how an metadata document looks like. Yeah, it's unsurprisingly a JSON object or JSON document. And it has information in it like what's the name of this issuer, which must be, the same as the authority. Where are the physical endpoints? Like here's the authorization endpoint, here's the token endpoint, and there are much more endpoints. Which scopes are supported and which authentication methods are supported, and so on and so forth. Yeah. One, for all practical purposes, really, really important configuration detail is what they call the JWKS URI, which basically points you to another document that describes the cryptographic key material that is being used to sign the tokens that are being created by the token server, and that in turn helps the client to find the right key material to validate the tokens. Yeah, because that material will change over time, right? So you can see this is actually an array of keys, and the whole idea is that the authorization server, either scheduled or ad hoc or whatever, can introduce new keys at any point in time. Okay, and that's called key rotation. Yeah, and that allows you to basically, again, for good crypto hygiene, to rotate your keys so that, again, attackers getting access to historical data have it much harder to attack your system. Okay, so takeaway number 2 is learn about metadata. Don't hard code your configuration stuff anymore. Start reading from the metadata document. Yeah, and actually, the little example I shown you earlier, like with this here, or also with the machine client, you can see that even if you're writing manual clients, yeah, you see that when I'm requesting the token from the token service, what I'm first doing is I'm getting the discovery document, and that's what they call it, the discovery document. And then I'm not hard coding in my source code here the URL to the token endpoint. I'm getting that URL from the discovery document, which is basically this metadata document I've just shown you. And that's exactly how you should do it, and that's exactly how Microsoft is doing it for their ASP.NET Core integration and so on. Okay, so I've mentioned the word OpenID Connect now quite often. What is this thing really? And what OpenID basically tries to solve is the user authentication problem. So, I've shown you this OAuth flow, and you saw the login page, right? So clearly the user authenticated to the authorization server before the authorization server returned the code, right? But if you look at what the authorization server actually returns is, on the front channel, it returns this authorization code, right? And that's just a random number. Now, on the back channel, when the client is sending that code to the authorization server, it returns the access token. And and I said earlier also, there's this rule that the client is not allowed to touch the access token in the sense of look inside the access token, right? So strictly speaking, if you're following these rules, the client still doesn't know who the user is, right? All the client knows is I've got a token for a user that I can now use to call an API. The API might know who the user is because inside the token there is information about the user, but I, the client application, don't know who the user is, right? And that's what led many people to start poking into the access token and retrieving data, and that's typically a bad idea because often this was not validated and so on. So long story short, what OpenID Connect formalized is an additional piece of data coming from the authorization server back to the client application that allows the client to learn about user-centric data and authentication-centric data. And that is what OpenID Connect calls the ID token. And that is a very bad name because it's confusing. It kind of implies that, like the Access token, you can use it to access something, but you really can't. So if you want to, be very smart, never use the word ID token here, or only if you have to, but always explain it to be like the authentication response, right? That is basically the information that the authorization server sends back to the client to describe to the client what happened during the authentication. And that could be things like the user ID of the user, or when did the user authenticate, or how did the user authenticate, and maybe additional data like, first name, last name, email address, your favorite color, whatever is important for the client application, right? And again, this ID token is a JSON Web Token, yeah. So as you can see, it has a header and a payload, but it includes basically user-centric claims. For example, as I said, how did the user authenticate? When did the user authenticate? Who is the user actually? That's the user ID, that's the display name. Yeah, these are all the things that the client finds useful to maybe, do authorization or adjust the UI, things like that. Okay, and this ID token comes back with the same back channel call as your access token. So ultimately, when we switch back to our sample application here, when I'm doing a full-blown OpenID Connect / OAuth protocol flow, you see that I'm actually getting back 3 tokens: the access token for accessing the APIs, the refresh token that is for token management, and the third token is called the ID token, which is, as we know now, not really a token. It's the authentication response. And when I put this ID token in here, you see that it's very much about the user and its authentication. Yeah, like subject ID, authentication time, authentication method is missing here. Yeah. Okay. So that is basically, there are many more things to say about OpenID Connect, but in a nutshell, it uses the OAuth mechanism because it's so popular, but adds this additional piece of data that allows the client to learn about the user's identity, which was in pure OAuth not possible. Okay. That's, as I said, the other thing that you probably need to or want to learn if you're building a modern security architecture. So, of course, there are many, many, many more things you could learn. But if you want to, focus on the latest or the essential information, I guess, I would recommend have a look at the OAuth 2.1 spec. This is not really a new protocol. It's more like removing features from the original OAuth that didn't stand the test of time, like basically focusing on these 2 flows that I just described. And then on top, here's the OpenID Connect specification. Here's another blog post I wrote actually some time ago that goes into reasoning why you only need to learn 2 flows and that's it. And if you care or are interested in how to secure your browser-based applications, especially the client ones like the SPAs and the WASM stuff, then I recently wrote a blog post that goes into detail here because that is a very, very common scenario. And then if you want to learn even more, I can point you to the 2 most important places on the web for these types of things. One is the IETF homepage, which takes care of all of the OAuth stuff and all the satellite specs around it. And on the other hand, there's the website to the OpenID Foundation, which takes care of OpenID Connect and all of their related protocols. Cool. So that's it from my point of view. So just to summarize that, OAuth itself is basically a token request response framework. They have some flows in there for interactive and non-interactive applications, but what they in essence do is say like, hey, you send this to the server and that's what you expect back. Okay. The difference between OAuth, I guess, and the WS Star family was that it was always built for interactive users, right? It was always built to incorporate the third-party access requirement, where you are going to some website, you are basically the website asks for your permission to access certain functionality of your data, right? And that was from the start a design element of OAuth, whereas in the enterprise world, this wasn't really like a thing. So the central piece in OAuth is the authorization server. Basically, I always imagine it like as a traffic cop that's standing somewhere on a busy street, that knows here are the resources and here are the clients, and that's how you can go, and these clients are allowed to access these resources, and I either allow you in or you have to wait, things like that. Maybe I'm stretching this analogy a little bit, but that's basically what it is. And OpenID Connect is basically an implementation of this OAuth base idea that adds features, so to speak, to enable authentication. Cool. So that's it from my part. So do you have any questions?
I've seen a few on the YouTube comments. Guys, feel free to ask. I will maybe start with one of my own. In these flows that you described, what I'm missing there is, I guess the authorization server is the one holding all the user data, the passwords, the stuff needed for the authentication handshake and stuff like that. How do we manage them? Is this part of like the authorization server? Does that expose some sort of API that I can build my own UI to manage the clients and stuff? Or what happens if my users live in some sort of another repository, like my Active Directory or something like that?
Yeah. So again, this is a complete implementation detail of the authorization server product you're using, right? Some products may only provide the OAuth endpoints and then connect to some fixed repository, like for example, ADFS, from Microsoft, is basically providing some protocol endpoints, but is hard-coded to use Active Directory behind it, or Azure Active Directory, right? Is another example of a product which basically is built for one particular user store. Auth0 has their own, because I see Auth0 mentioned here. Auth0 has its own user store as well. Some products have extensibility points where they can connect to other user stores. IdentityServer, for example, is a framework that is by design, like built from the ground up to connect to arbitrary user stores. So it really depends what OAuth product or framework you are using, I guess.
So provided that I use one of them and I have a user store somewhere, do the APIs themselves need some sort of storage of those users on their own to understand stuff like user roles and stuff like that, or where would that fit in?
So you're talking about authorization of users, I guess. So basically, user authorization is not a concern of OAuth at all. The authorization server, as I said earlier, OAuth's job ends once a client has a token. Okay. Now, when this client connects to the API, all the API knows is, okay, the client can connect to me, but like a really good example is if you go to some page that wants to access your Twitter timeline, right? So it asks for the permission to access your Twitter timeline. Yeah, so all the authorization server knows is that this client wants to access the Twitter timeline, but you can still only access your own Twitter timeline and not the one of arbitrary other users. Yeah, so there are two different concerns here. One is client authorization. What is the client allowed to access? And once the client accesses it, yeah, the resource that is being called needs to do its own user authorization decisions. And where this data is coming from, well, that's an application concern. Yeah, that the authorization server is not involved in this decision in any shape or form.
Right. Okay, so the first question from YouTube was, what about services like Auth0? This is basically third-party authorization server which knows about my services. Is it still following the guidelines in terms of tight connection?
Yes. So Auth0 is basically like an authorization server as a service, right? So if you think about it, you are basically becoming an Auth0 customer to run an authorization server for your own services. Yeah, like as I said, as a service. Yeah. So yes, they absolutely follow those guidelines, but it's, as I said, it's a multi-tenanted software as a service product. I mean, it's the same as Azure Active Directory, for example, right, where you run your own, tenant in there for your own services. So yeah, this is absolutely following the guidelines, but it's a software as a service product.
Mm-hmm. All right, the next question is, looking back at the decision of making IdentityServer open source, do you have any regrets making that decision?
Yeah, we should have done it. Looking back at the decision making open source. Well, it was never not open source, right? So from the very start, IdentityServer was pretty much an evolution of a big blog post I was writing. Yeah, basically. That was around 2009, I guess. Yeah, like 12 years ago. I was that was maybe a little bit earlier. That was when Baier became popular, which was the Windows Identity Foundation, which was a .NET library for building token services. I became interested in that and blogged a lot about it. And at some point, the sample became too big for a blog post. So I was looking for a place to put the sample. And by the time there was CodePlex, and that became the very first version of IdentityServer. It was called Starter STS by the time. So open source or not open source was never a question. And I see a lot of value in open source. And I never regretted it. Yeah. What maybe the question is alluding to is, do we regret in the move to make it more commercial, or was it too late or too early or whatever? And yeah, I don't know. It became a problem to maintain. The bigger the code base became, it became a problem to maintain it. As much as I like the idea of open source, in the end, it still was our responsibility to run the project, right? To decide which feature requests we're taking and so on. And no one ever felt like stepping up and taking part of that responsibility. So, and that I think is a problem that many of the classic free open source projects struggle with, that people come in, want to have a specific feature, and once this is implemented, they're gone again because their job is done. So it becomes just harder and harder for like a project governance point of view and a roadmap point of view, that we had to create a company around this to make this work. And I was misreading this question, if we ever regretted to turn this into a commercial thing or create a company. And the answer is clearly no, we don't regret that. Actually, we think this made it much, much better. And ensures a good future for the project.
Nice. The next question asks about the BFF pattern that you mentioned. You've published a package which helps with implementation of backend for front-end pattern. Do you think that classic SPAs are unsecured without BFF? Will BFF standard be a standard for securing SPAs?
So my personal opinion is that you should not store access tokens in the browser. It's too dangerous. We have a long history of cross-site scripting style attacks in browsers, and OAuth, and especially the implicit flow and some other things, they encouraged you to drive all the interactions with the authorization server from the browser, from the client. This all has the consequence of that you need to store these very sensitive access and refresh tokens in the browser itself. And while this might be okay for applications that don't have high security requirements, right? But if these tokens secure important information, like banking, healthcare, I don't know, like portals of cloud providers, I mean, things where attackers are interested in because they can take advantage of abusing this, I would be scared to death to store these tokens in the browser. So yes, I absolutely think that the BFF pattern is more secure. I'm not saying that switching to the BFF pattern makes your application automatically secure, but the threat model looks so different if you can at least make sure that you are safe from token exfiltration attacks, which would allow an attacker to make arbitrary calls against your backend.
Then Praise asks, what is a good way to handle registration if you need to redirect straight to the registration page? Would you still use the authorization endpoint somehow?
So that depends on if you want to do registration as part of the authentication flow, I guess, If that is one option, then maybe your journey starts at the authorized endpoint, but then it says like, are you a new user, ? Right? And if they click that, and you could, inject a whole registration workflow, technically speaking, at least, If that is practical, depends a little bit on how involved your registration is, right? I mean, you should have things like email confirmation and so on. But technically you could do that, absolutely, But maybe it is more practical to ask this, are you a new user question in the client and not on the authorization server, and just focus at the authorization server on the authentication workflow instead. But I mean, depends on the use case, I guess, Technically, if possible, if it's practical, as I said, depends a little bit on more details, how your registration actually works.
Tomas just saying thank you. You did a great amount of work, and gave amazing gift to the .NET community. Thank you.
You're welcome.
We don't have any more questions in the comments, so maybe just to close up. So let's say I'm a .NET developer. I want to implement the OAuth protocol. What are my most straightforward options to do that? I guess IdentityServer baked in the ASP.NET Core and all the other Microsoft frameworks is one way. You mentioned Azure Active Directory. Are there any other options? And what should be my main differentiators? What should I base my decisions on to select the solution for me?
So there are many OAuth and OpenID Connect products out there these days. Obviously, like this being a Microsoft-centric user group, that the most visible ones are probably the ones from Microsoft, which is Azure AD. But Azure AD is very much focused on enterprise / employee-centric scenarios. So this is, in my opinion, even if they try really hard, not a really good solution for consumer-facing applications. So, if what you're looking at is OAuth for employees and securing company resources, I think Azure AD is a pretty stable solution, for example. There are other products out there, and like on-prem, the classic on-premise one versus software as a service. We mentioned Auth0 earlier. Auth0 is definitely one of the bigger software as a service companies that focus on the consumer-facing side of things. And at the other end of the scale, I guess there's also IdentityServer, which is not a product or a service, which is a framework. So what I often tell my customers is that if you find a software as a service product that does everything you need, then probably you should just go for that. I mean, if all of the requirements are hit and you are happy with the fact that your user data is stored in the cloud or whatever, and that the whole login problem is not a problem for you, that probably is the best use of your time. The reason why IdentityServer exists is because we have so many customers where an off-the-shelf product does not work. Because they have one or the other requirement, and that might be, for example, it must run in offline mode, or we want to connect to an existing legacy database, or we have these very specific migration scenarios, or there are so many scenarios that are not handled by standard products, that make a framework solution like IdentityServer more attractive. So it really is basically based on, does the product have all the features I need, and all the features I anticipate to need in the future? Do I want to have a cloud-based solution, or does it have to run on premise, or at least on my own servers? And then I guess if you go to the website of the OpenID Foundation, there is a page for certified implementations, and that is definitely a good place to start. Because they are basically, they went through a certification process like we did too, and every product on that list at least proves that it is, from a protocol point of view, spec compliant. So that's definitely a good place to start.
We had one more question come up from Brock Allen. When is the last time you had a haircut? Inquiring minds wants to know.
So Brock is, by the way, the other guy that works on IdentityServer. He probably should know when my last haircut was, because he's often also called my second wife. So if I can disclose this information here on this private round. The answer is, I think, a long time ago, because in Germany right now it's not that easy to get one.
Okay, I think that answers everything then that we wanted to know. Thanks a lot, Dominic. I think it was a really interesting session, and hopefully, one day we can do this in person in Prague and buy you a beer afterwards.
That is something I will remember.
You're always welcome.
Cool. Thank you.
Thank you, everyone, for joining in, and see you next time.
Bye-bye.